Hey you guys, this is Mr. Sal. We're going to do a quick lesson on factoring and the greatest common factor, and also factoring by grouping for these polynomial stuff. So thanks for watching, and don't forget to like, comment, and subscribe. We have a hard time wrapping our minds around this factoring stuff, usually because it's so weird. We just don't do it very often in our everyday lives, that when we tell you to do it in math, especially when we've told you for so long to distribute, that you're like, I don't know, what the heck is going on over here, okay? And that's perfectly natural if you feel that way. It just means, again, that it may take some practice before we really get used to this stuff, all right? It does play a pretty big role in other modules as well, so it's pretty crucial that we get used to this factoring stuff. We remember, hopefully, with some of that domain stuff, right? If we saw something like this, well, then we would say x could not be 6 in the domain, right? Well, if this was 36 times x minus 6, now I could cancel out the two x minus 6's with each other, because anything divided by itself is 1. And then the answer to that now is just 36. It is the reverse of multiplication, kind of like addition and subtraction kind of undo each other, or multiplication and division undo each other. We haven't looked at this too much, but something like an exponent, like a squared, that is undone with square roots. But now we're looking at factoring and, I guess, multiplication of polynomials specifically. So a factor is just something that's being multiplied by something else. And when we look at common factors, we can pull it out and make it look like an expression when you're going to distribute, like before the distribution stuff, okay? Greatest common factor is just the factor that's the greatest of all of the terms. And we're going to yank that out from the terms, okay? So something that would be easy for us to see. Something like 5x squared plus, I don't know, 10x, okay? So factoring means I'm going to pull stuff out from not only the 5x, but I'm going to pull the same thing out from the 10x. But they're multiples of the two, okay? So for example, I see that 5 is a multiple of 5x squared and 10x. So I could yank out a 5. But they also have x's in common, so I could yank out an x as well. So the greatest common factor for this is 5x, which produces a new expression for us, 5x, and then inside the parentheses would be whatever remains from the 5x squared and the 10x. So the 5x squared, all that remains is just the x, because we yanked out the other two multiples, 5 and x. And then from the 10x, we would yank out, well, we yanked out the 5x, so we have left over just a 2. That's a positive 2. So this is considered factored right here, because I took out all the greatest common factors. All right, so in this example, it says just to factor out the greatest common factor. So we're not necessarily looking for a binomial, a polynomial to yank out yet, but that is coming. So I'm going to look at each individual term, and I'm going to factor it, or look at the factored form of that term. We don't really cover a lot of factoring before, but by factoring, this is what I mean, all right? So I got 38, a to the 6th, b squared, c to the 8th, all right? This is what we call a factor tree, which we need to use. Well, we'll be looking at factor pairs later on, not necessarily the tree. So 38 can break up into 2 and 19. Oh, actually, that's not too bad. So this ends up being 38, I'm sorry, which broke up into 2 times 19, right? And then we still have that a to the 6th, which I may decide to break up later. I don't know. It depends. You know, what the heck. I'm going to take those, I'm going to write it out completely just so we can see one example of that, okay? So this is just this term factored out completely. We've expanded all of the exponents so we can see each individual c, a, and b. So if I multiply this all together, I would get my original term right here. Next up, let's look at 10 a to the ninth, b to the fifth. 10, I would say let's break that up into 5 and 2. And those are prime, just like the 2 and 19 were. So we can't really factor that out anymore. So we're going to break this up into 5 times 2. We got 9 a's and 5 b's. Well, there's a good example for you guys to see why I write in all caps usually when I'm freehand. All right, let's do the same thing with negative 18 a to the 7th b c cubed. All right, now that we factored out the negative 18, we just have the 7 a's, the 1 b, and the 3 c's. There we go. We have all three factored forms. Now I have stacked these like this, kind of like as if we're doing some kind of elimination method thing. I've done that on purpose so that I can find common factors, all right? So GCF, greatest common factor. So I'm going to find all the common factors that I can for all three of these terms. And right now, just in the numbers right there, I've got this 2, that 2, and these 3 2's are common, which means for my greatest common factor, I've got a 2. Now there's no other 19's in common, no 5's in common, no negative 1's, and no 3's in common. So that's it for the numbers for the greatest common factors. Now we have to look at the letters, and there's a lot of a's in common on this, right? So I'm just going to highlight these. Hopefully that'll help us a little bit. So I've got this set of a's, 1, 2, 3, 4, 5, 6 a's in common, all right? So I can write that out as a to the power of 6. We don't have a lot of b's in common, just one set of b's. So there's a b, only one though. And now we got the c's as well. Nope, I don't see any c's in common. Specifically because of that middle row right there, right? The 10, a to the 9th, b to the 5th had no c's, so there were no c's in common. All right, so we have identified the greatest common factor, which was the first part of this. 2a to the 6th, b. So I assume you'd have to fill that in on the homework. Now it says the greatest common factor out of the expression. So our greatest common factor right here is 2a to the 6th times b. Now we factored it out of something, specifically those three terms from the original expression up here. So I'm starting with that 38a to the 6th b squared c to the 8th. And what do I have left over? I've got a 19. I've got 1b. And I've got 8 c's. So there's that term. Next up, I'm looking at the 10a to the 9th, b to the 5th, and I've got a 5 left over, which is positive. I've got 3 a's and 4 b's. So that's b to the 4th. These are all multiplied, so it's b to the 4th. We have the exponents. And finally, we got this final term, the negative 18 a to the 7th b cubed. There were 3 numbers left over on that, right? We got negative 1, 3, and 3. So we're going to multiply those together, which would give us negative 9. Then I've got this a left over and these 3 c's. Bam. That's my factored expression. This is just the foundation of how you do it. It's not necessarily how you guys will choose to do it later, because we can use exponent rules and stuff later on as well. Same thing on this one. We'll identify the greatest common factor and factor it out from these 3 terms. So we'll just multiply the greatest common factor by a trinomial in parentheses. And on this one's not too bad actually. Right? We got 5x to the 5th, which, I mean, just broken down is just 5x to the 5th. I'm not going to expand the x to the 5th, and I won't be doing that anymore, but you could if it helps you, all right? 10, though, I can break up into 2 times 5. Then we got x cubed. And then 35 breaks up into 7 times 5 with an x squared. Yeah, we got the addition in between these, which is important if it were subtraction, all right? Well, I can see my common factors of 5 for each of these. So I could yank out the 5 first, but I could also break these down into x's. And I'm looking for my lowest degree x, my x with the lowest exponent, which in this case specifically is this x squared, right? So in other words, this x to the 5th breaks up into x squared times x cubed. X cubed breaks up into x squared times x, and x squared is just x squared. So I'm looking for common x squareds here, so I can yank it out as part of the greatest common factor, which we have. We got this x squared, this one, and this one, which are all common. So our greatest common factor is 5x squared. Well, that is just the greatest common factor. We need to multiply this, though, by whatever else was left over on the inside of the parentheses. And if I look at these terms, the first one I had the x cubed remaining, so I'll write that in as the first term. On the second term, I've got the 2x to the 3rd power. I'm sorry, this is the x because we broke that up, right? So I've got remaining a positive 2x, and then my third term I've got just only a 7 remaining, and it was positive. Bam. That's it. So this would be my two answers. All right, this one looks very different. In fact, this is considered only a binomial because I've got two factors in the first term. One of the factors is considered 3x, and the other one is a binomial. On my other term, I've got a 6, and then it's being multiplied by a binomial. So right now, the whole thing is considered a binomial, because I've only got the two terms. Now, we're looking for common multiples in this thing, though, right? So,
Would you distribute first?
That's what we would want to do, is to distribute first here, right? I would multiply the 3x into the parentheses and then the 6 into the parentheses. However, since I'm looking to factor instead of distribute in this case, I can see that I have a common factor of 9x to the 4th, 9x plus 4y and 9x plus 4y. So just like we've been doing, I'm going to yank that out from these two terms, okay? So I've yanked this 9x plus 4y. I'm going to keep it in parentheses. And then what did we have left over? We had a 3x and a 6, right? Plus 6, which also would be in parentheses. Now, I actually get the feeling that this would not be the final answer, which makes it a little bit tricky, okay? Does anyone see anything we could factor out of either one of these?
3x.
It's close. It's close. So the 9 and 4 don't have anything in common to factor out, right? 9 breaks up into 3 and 3, 4 breaks up into 2 and 2. They have x and y's, but what about the 3x and the 6? Well, 3 is just 3, but 6 breaks up into 3 and 2, right? So technically I've got a 3 in common from this set of parentheses. I'll use a different color. I can yank out this 3 from this set of parentheses as well. So this ends up being 3 times, well, what's left over, the x and then the 2, right? And this is still multiplied by 9x plus 4y. And this was what I would consider fully factored. It's possible that the homework may want that 3 in the front. All right, polynomials that cannot be factored further are said to be factored completely, which you will see some of those on the homework. The factors in the resulting factorization are said to be prime polynomials, yeah, because you can't factor anything. When the leading coefficient is a negative number, yeah, that's true. When our leading coefficient is negative, we usually yank out a negative as part of the greatest common factor, even if it was just a negative 1. So if you saw something like this, negative 9x squared plus 4x minus, 13, for example. None of these have, the 9, 4, and 13 have no common factors. So you would say, well, maybe if it wanted to, we could yank out a -1 out of that, and then just change the signs. Now, it's not common for us to yank out a -1, but we could if we wanted to. And if there were any common factors, we would yank out a negative, whatever that common factor is, okay? It has only, and that's only specifically because that leading coefficient was a negative. That's pretty much all. So this leads to factoring by grouping, which is kind of what we saw in that last example. Not the one I just did, but in the one from the homework. Now, the largest common factor is sometimes a binomial, which, again, we did see, right? Often in order to identify a common binomial factor, you've got to regroup. So we'll be looking at polynomials, usually 4 terms. If it's not in 4 terms, sometimes we have to break it up into 4 terms, which is where some of the complications we run into in this class happen. But don't be discouraged. We have our methods, all right? So this one sets up pretty nice for us. Yeah, it looks pretty good. It looks like it could even be rearranged just a tiny bit, but we should end up with the same answer. Now I say that we could rearrange it just because sometimes you will need to, all right, so that it can factor better. So factoring by grouping means that I'm going to change these into 2 separate binomials, and we have addition between, so it's not going to affect anything inside that parentheses. And I'm going to factor these 2 sets of parentheses separately. And then after I factor them completely, hopefully we find a common binomial factor that we can factor out from there. Just like we saw in that last example, all right? So just starting with the 14xy plus 63x, right? 14 breaks up into 7 and 2, and 63 breaks up into 7 and 9. And you could break the 9 up into 3 and 3 if you wanted to, but the 3's aren't common with the 7 and 2. What is common is the 7's and the x's, right? So I've broken this down, factoring by grouping, which is nice, into 2 separate factoring problems, okay? So from that first set of parentheses, I can factor out a 7 and an x, and then inside that set of parentheses, I had left over the 2y, and then this is plus 3 times 3 is the 9, and there are no letters with the 9. Well, that takes us now, because we're breaking this up, into our next binomial. So 6 breaks up into 2 and 3, and 27 breaks up into 3 and 9. Again, I'm not going to break the 9 up any further, because, I lied, I am, sorry. I got the 2 3's, which are not common with the 2, right? So this breaks up, I can yank out from this, it looks like 3's from these 2 terms. Those are positive 3's, by the way. And then we're looking at what's left over, and we should, if things work out well for us, we should be able to have inside this other set of parentheses 2y plus 9, if we've done it correctly, all right? So what is left over from the 6y? Let me use red here. I got 2 and then the y. So that covers the 2y part. And what's left over from 27? 3 times 3, which is 9. Now, you may think this doesn't happen all the time. It does when we want it to, all right? And we want it to often in this class, enough for you to get the experience you need to factor by grouping. So, just like we did in that last example, so we broke it down into 2 separate binomials like that last example. And yeah, we can see that I've got a 2y plus 9 that is a common factor for both terms. So I can yank that out, 2y plus 9. And then what do I have left over? I've got the 7x plus 3. That's a 9. And that is, that's factored. So on this one, let's say that you said, I'm gonna try to factor out the greatest common factor from all 4 terms. Well, we already have the breakdown for these, right? Are there any common factors to take out of there?
Oh, good point.
Right now, there isn't, right? Now, eventually there will be. We'll see some examples that do.
Okay.
But if that fails on us, if we say, look, there is no common factors between all four terms, then the next step is to look for factoring by grouping like we just did. So yeah, by instinct, let's look at this one as well, right? Is there any common factors I can yank out of all four terms? Now the 3 and 4 should be pretty good indicators that we cannot, because the 3 and 4 have no common factors except 1. Now if the 4 had a 4x instead of a 4y, we could yank out an x from all four terms, and that would be okay. Even then, after we did that, we would be looking to group factor by grouping as well. So we'll just jump right into factoring by grouping on these. So we'll start with this set, and then we'll move on to this purple set right here. Again, if that was minus between these two, we'd have to be careful with how we're doing this. All right? All right. So let's look at the 24x squared plus 32xy. So 24, this is going to break down into, well, you could say 2 and 12, which breaks out into 3 and 4. And then we got 2 and 2, right? I'm going to keep those there so we can keep those in mind. If you wanted to, you could put the x squared like that. 32, this one's going to break down into a lot of 2's. And yes, this is prime factorization here, right? 2 and 8, 2 and 4, 2 and 2, and then we got the x and y. So looking for common factors, I've got 1, 2, 3 2's, which would combine 2 times 2 times 2 is 8. But not only do I have those 3 2's, but I have the x's which are common. So I've got an 8x. The rest of it stays inside that parentheses there. And what was left over? I got a 3 there and an x. So 3x. And over here I've got 2 times 2, which is 4, and then the y. So 3x plus 4y. If you ever doubt yourself, like, man, I think I did this wrong, just redistribute the 8x back into the parentheses and see what you get. If you get something different than 24x squared plus 32xy, which is what we started with, then you know somewhere there you've done some factoring wrong. Yeah, so the 2's in green, that are circled in green, those were common with the other 3 2 circled.
Yeah, okay, that's where I was lost.
Yeah, so we got, I'm using the wrong color there. These 2 2's, 2 times 2 would give us that 4 right there.
Okay, thank you.
Yeah. All right, well, let's look at that 3x plus 4y. Well, we already kind of addressed that. There's no common factors for 3x and 4y, except there is 1, right? So why would we want to pull a 1 out? Just so we could see that it's plus 1 of these 3x plus 4y's. The 1 helps us, it usually helps students mentally see that we're going to yank out from this binomial now the 3x plus 4. Because right now all I'm going to do is I'm going to factor out from both of these terms 3x plus 4y. And now hopefully we can see why that 1 being there is pretty important, right? So I'm factoring out 3x plus 4y. And what did we have left from that? We had the 8x. And that's where that plus 1 is really nice to see. Because now I know I need to plug that in right there. And that's my answer. This one is very different than the ones we've just been doing, actually. So if you struggle a little bit, that's okay. All right. For example, and like we addressed, right? If we looked at this, or as we've been looking at these, hopefully our first instinct is to find the greatest common factor for all 4 terms. And there is a greatest common factor for all 4 terms that we could factor out. Now, whether you found it like that or not isn't necessarily important, because it doesn't matter which way you do it, as long as in the end it comes out. So from the beginning, I mean, since you guys I had already done it. I'm going to factor this out in a very convenient way. All right. So, for example, I had 6 and 20 on this, and then 90. I factored out. So I also have 6 and 15, and then 96 breaks up into 6 and 16, and 72 would be 6 and 12. So it looks like we got a 6 that is common for all 4 terms that I can factor out from, well, everything on this. But what do we have left over? So from this first term, I've got that 20 and the xy. And from the 90, I've got the 15. So 15x plus the 16y. And then in this last term, we got a 12. Now, just to check, I mean, we could look at these and just see if there's anything we could pull out from all 4, right? So 20, 16, and 12 have common factors of 4, but 15 does not. So that doesn't work. Yeah, there's nothing that works right there. I mean, 15 and 12 have a 3, 20 and 16 have a 4, whatever. There's nothing else I can pull out of that. But now that I've done that, and I still have my 4 terms, I should look to see if I can factor by grouping. So I'm going to look at the 20, xy, and the 15x. And the 20, I'm going to break down into 5 and 4. You could break the 4 down more. But again, since you guys had some time to do it, we're going to skip that part. So I see I've got a 5 in common, but also an x in common between these 2 terms. So inside this big set of parentheses, I've just yanked out a 5x from those first 2 terms. And what am I left with? 4y. And then it looks like I've just got that positive 3 right there. Next up, let's look at the 16y and the 12. So 16 breaks up into 4 and 4. 12 breaks up into 4 and 3. So I've got a 4 that's common between these 2, and no letters. So I'm going to yank out that positive 4, and then inside the parentheses I've got the 4y and the 3. Now again, I didn't point it out this time, but notice these are the same, the 4y plus 3, right? Just like we've seen before. So that 6 that's outside, yeah, we're going to leave that alone, because if I decide to distribute that back into it, I'm going to have to factor it out eventually anyways. So I still got that 6 in front, but from these 2 terms, right, I can factor out the 4y plus 3 from both of those. And then outside of that, I've got the 5x and the 4 in this set of parentheses. Now notice, right here, I put the 6 outside a second set of black parentheses, which is not necessary for this, right? Because now it's just all straight multiplication between the 2 binomials and then the 6. Well, actually, that's as far as we can take this one. Yeah, so let's look at factoring by grouping just to start out with, and then we'll do the greatest common factor later, right? Well, if we get that far. So the 120, you saying you factored out a 2, and then 60. Did you continue factoring?
Yeah.
So that's 2 and 30, 2 and 15, 3 and 5. Of course, we got the x and y still. And then 90 factors into, right, and I'm sorry, we're focusing specifically on factoring by grouping. So just these 2. And 2 and 45.
Oh, wow, I did 2 and
Maybe
3.
9 and 5. Because the 15 and 3 would break down into 3 and 5 as well.
Okay.
So I still got 2, 3, 3, and 5 from the 90x. So I'm going to identify the x as well. So what can we pull out of this? I've got a 2, I've got a 3 in common, and I've got a 5 in common. So 2 times 3 times 5 is 60. And I've also got an x in common for both of these. And then what do we have left over? Did I miss a 2? I apologize, 30. That makes a lot more sense now. So, yeah, what did we have left over? 2 times 2, which is 4. And then the y. And then over here, I just have a 3, positive 3. And we've seen that 4y plus 3 already, right? Well, let's continue with that, and then hopefully we'll make a little bit more sense. 96y, so 2 and 48, and 2 and 24, 2 and 12. I'm only using 2 because dividing by 2 is pretty easy, right? 2 and 6, 2 and 3, and then 72. Let's do this one a little different. Maybe some of you guys use 6 and 12. And then we got 2 and 3, 3 and 4, and 2 and 2. So what do we have common here? I've got 1, 2, 3 2s, 1, 2, 3, which is 8, but I've also got a 3 in common for both of these as well. So 8 times 3, that's a 24 positive.
So you multiply all of those.
Yeah, and there's no letters here
So I
that are in
wrote it
common.
down.
So what do we have left over in there? We got this set of 2s. 2 times 2 is 4. And I did have the y left over as well. And then from the 72, it looks like I've just got the 3. Again, we've seen that already, right? So I can factor out from this my 4y plus 3. And then what do I got left over? I got 30x. Ooh, that's a 30x plus 24. Now, if you stopped here on a test, I mean, you'd get a lot of the credit. The problem is that we have this 30 and 24, which can still be split up, right? So I'm going to just simplify this. 6 and 5 and 6 and 4. So there's that 6 again, which I can pull out, which makes that 6. And then inside the parentheses, I'd have 5x plus 4. And then, of course, we had the 4y plus 3. Now, the way we did it before, the 6 was over here, right? I don't really care where it is, in the front or the back. Maybe the computer does, though. But, again, we've simplified it completely, just in a different way. On this problem, if we just group this right away, which is, again, what we may be inclining to do now. 12p in the q, and then we got the 4 with the 3qp. There's nothing to factor out between these two. That just means they're grouped wrong, which means we need to regroup them. So we're going to take those away, and let's rearrange this. All right. Let's start with the 12p, because right now it's our leading term. Well, it's not necessarily, or technically the leading term, but whatever. 12p, it doesn't go with the q. So do you guys want it to go with the 4 or the 3qp? 4. All right, so I'm going to make that 12p plus 4. And then I'm going to make that q plus 3qp. All right, so all I did was rearrange things so that I can group differently. All right, now, why did you guys move the 4 there instead of the 3qp? Just out of curiosity.
Because I know that 3 is going to end up with the 12, and I want 3qp
Okay, all right.
together, right?
Good, that works. And that's okay, all right? Some of you guys may have grouped it with the 3qp, which would still work, because 3 and 12 go together as well, all right? So it didn't matter which one we chose, we should still end up with the same answer. But let's start grouping these now. So 12 and 4. So again, instead of doing this with complete prime factorization, I'm just going to try to find any common factors like 4 and 3. And then 4 would break down into 4 and 1. So this would be considered listing factor pairs. Okay, so instead of 12, maybe you use 6 and 2, but you found that didn't work. Well, now I have a 4 in common that I can pull out of that parentheses. And I have left over a 3p plus 1. Well, what about this set? No numbers. But I can yank out a q, right? I've got a q in common. And that's a positive q there. So from the 3qp, I've got a 3p left over. But what's left over from the q? 1. Very good. Now these look different though, right? So if it, not that this step is completely necessary, but over here I've got 4 3p plus 1. And then I'm adding this to q. If I wanted to, I could use the commutative property of addition, just so I feel better inside, to make that look exactly the same, 3p plus 1. Now I yank out that 3p plus 1, And what am I left with? I've got the 4 and the plus q right there. And that's factored. Yeah, if we made that 1 a 0 there, then if we factored the q back into it, we wouldn't end up with what we started with, which we have to do. So we made that phantom 1 not phantom 1.